So last time we started section 1.7, which was linear and absolute value inequalities. Okay. And we had gotten to, I think, this one, D. So let me remind you where we were on C because it leads into D very nicely. On C, there's two inequalities, and they have the word and in between them. And means they have to satisfy both inequalities at the same time, right? That's what and means. Now, when we look at part D, the word and in the middle is no longer and, it's or. And when we have the statement of or in between, it means it needs to satisfy one condition or the other one. And it could satisfy both at the same time. It's possible, but it just needs to satisfy one condition or the other. So we're going to solve these just like we were solving on the previous problems that we were working on. And then we have to consider a number line in order to figure out which pieces of it actually have the ability of satisfying one condition, that is one inequality, or the other one. So taking a look at the first inequality, 4 minus x over 2. On that one, what would we do first to solve that? Multiply by 2, that's exactly right. So if we multiply by 2, I would get, hang on, let me change this to white. A little bit easier to see. I have 4 minus x on the left, and it's greater than 2 on the right. Now what would I do? How about the 4? The 4, yeah. Subtract the 4, you're right. So now I have negative x, and it's greater than negative 2. And then there's that negative that came up. So that came up last time when we talked about that when we divide or multiply by a negative value, we change the order of the inequality. So now my x is less than, and then negative 2 divided by negative 1 would be positive 2. So in terms of a number line, there's going to be a 2 on it. And which direction will I shade on the number line to give the values that are less than 2? Right or left? Left. So these are the values that satisfy that inequality. Do I use a parenthesis or a bracket?
Parenthesis.
Yeah, it's parenthesis because it doesn't have an equal sign, right? Parenthesis opening towards the shading. All right, the other half of the problem then is another inequality. On this inequality, it looks much like the first one, but I'm multiplying this time by a negative 3. So on this one, I'm actually multiplying by a negative, but multiplying by a negative also changes the direction of the inequality. So I have that 2x minus 7 from the numerator, but now it's greater than, and then I have negative 3 on the right-hand side. What would I do next?
Add the 7.
Add the 7, you bet. And that gives me 2x is greater than, and then negative 3 plus 7 would be 4. And then I would divide by my 2, and x would be greater than 2, right? So the 2 is already on my graph. A lot of times these numbers don't match. Here, we put the other number on there and compare, of course. These actually do match. So the 2 is already on there. Now, what direction am I going to shade according to this one? To the right. So this is a little different, right? I mean, it looks like everything's shaded, at least almost everything. Because what's not shaded? The actual value 2, right? Because I haven't put it in yet, but there's parentheses on both of them. If either of them were a bracket, that would be everything, but it isn't on this one. So if we're taking a look at writing an inequality on this one, we would actually have negative infinity to 2 with a parenthesis. And then we would have another parenthesis starting with 2 and going on to infinity. And the symbol that my math lab will probably have you put in between them is a U. If you're working it for me, I don't necessarily have to see a U, but it may require that in my math lab. Okay, U just means union. It means joining them together, like union of a marriage, right? Joining it all together. So this is what we would have for our inequality. Any value that's either less than 2 or greater than 2 solves either one inequality or the other one. And that's what we're looking for in this problem. Notice, if this said and, the answer would actually be no solution. Why? Yeah, there are no numbers that are both less than 2 and greater than 2. So that word in the middle is a big deal. Notice also, I didn't mention it last time, but we'll go back and take a look at this one. If this value in between, this word in between, had said or instead of saying and, I would actually have any number that would work. Because any number would solve one of the inequalities or the other one. Because the original shading in the blue and the yellow covered the entire number line. It's the overlap I was looking for here because it said and. So those and or have a very unique relationship to the problem. All right, the last bit of this particular lesson actually has to do with absolute values. So the lesson title says linear inequalities and it says absolute value inequalities. And the reason we did these last two problems with the ands and the ors is because they come up with inequalities for absolute values as well. So on the first one, this one says that the absolute value of x is greater than k. So what we know is that this means, from what we've already done, that the absolute value of x could be greater than k, right? We could, if the values are positive, right? If I just lift the absolute value off, I would actually have a value bigger than k. The other possibility is that I actually have an x value that's actually less than negative k. And the value or the word that goes between them is the word or. There's that or coming up again. Here's what I'd like for you to see. This sign, and I know I spelled it wrong, is a greater than sign. And you have at least the sound of the word or in the word greater, right? So that's one mnemonic device to help you to remember that a greater than becomes an or statement. Now, in terms of an inequality graph, right, a number line, I don't know where the numbers themselves, did I put, yeah, I got that right, are, but here would be my negative k and here would be my positive k, right? So remember, absolute value tells you that the value's distance from 0 is greater than something. Well, if the distance from 0 is greater than k, and here's 0 in between, by the way, then that means it has to be over here. And the opposite is that the value itself could be, again, greater than k away, but in the negative direction, and that would be over here. We're still going to use our inequality parentheses and brackets in the same way. So if we have an equal sign, we're using brackets. If we don't have an equal sign, we use parentheses. So on this one, I don't have the equal sign, so they are parentheses. And if I were writing the interval notation, it would be negative infinity to negative k, and then k to infinity, because it's an or statement. And then interesting things happen when you actually have a less than statement. So, just like above, let me make this just a little bit smaller, just a sec. This is a less than. I know I spelled it wrong again. I know, it's crazy. But it has that and sound at the end of it. And that can help us to remember that we're going to end up with a statement that has the word and between. So what do they look like? Well, one of the statements looks exactly like the one I already have. X is less than or equal to k. The other one switches the sign, so it's greater than or equal to, and it changes the value to negative. Now, there's actually an easier way of doing this that you may be familiar with. We'll say another option because I don't want to write the word or since I can use the word or specifically for something else above. Another way to write this is that you can write negative k is less than or equal to x is less than or equal to k. So you can write it sort of as a sandwich or a triple inequality. Either way will work, and it will be fine. It's your choice. If you think about from the number line perspective, this is actually telling me from a number line that I want a value, here's k, and here's negative k, whose distance is less than k away. Well, if you're less than k away, then you're closer to 0 than you are to k, right? You're not going to be further away than k on either side. So you end up with the stuff that's sandwiched in between negative k and k. And this one I have actually less than or equal to, so I've got the brackets on this one. So this would be negative k to k in terms of an interval notation. So this is the one that I tend to go with because it sandwiches it in a visual very nicely. So in other words, when I see the word and, I'm thinking triple inequality. Okay? If you just want to put the word and between, though, it will still work. You just have to be a little bit more careful with drawing your graph and remembering that and means overlapping pieces. Okay? So let's do a couple of examples of this, and then we'll be done with this lesson. Okay, so this is what symbol between? What's the symbol? It's a greater. It's an or one, right? Yeah. So this says or. Or means I have to write the two statements separately. Have to. I don't have a choice. So the first statement is 3 minus 2x, and it looks exactly like what I start with. Just lift the absolute values off. And then the other statement has the same values on the left-hand side. This direction of the inequality changes, and the sign on the right-hand side changes. Okay? So I've got less than or equal to now, and I have negative 5. I solve both of these, of course, in the same way. I'll subtract my 3. So I have negative 2x is greater than or equal to 2. I'll divide by negative 2, remembering that negative 2's change directions of inequalities. So it's less than or equal to now negative 1. And on the other one, again, I subtract my 3. All the steps are going to look exactly alike, but my values on the right-hand side will be different because negative 5 minus 3 is not 2 or negative 2, right? I mean, it's not going to be the same values any longer. I actually have to do the subtraction separately, and it's negative 8. And if I divide by negative 2, then x is less than or equal to 4. I didn't change my sign. It's like there's something going on wrong. That's what it is. There we go. Greater than or equal to 4. Change my sign because I divided by negative. Okay, everybody good with that? All right, it's an or statement. So in terms of a number line, I can put my two values on there. I have negative 1 on the left, have 4 on the right. How will I shade for negative 1? To the left or to the right? To the left. It says less than. And I'll use a bracket because it says less than or equal to. How will I shade around 4? To the right. And again, it says less than or equal to, so I have a bracket. And it is an or statement, right? So or means that I can use either piece. So my inequalities answer is actually negative infinity to negative 1, bracket, union, 4 to infinity. Okay, I get both pieces separate. Any questions on that one? Okay, one more. So if I did the last one, it's an or. You know this is going to be an and. But can you see that it should be an and? Yeah, it's a less than sign, right? Less than and. So again, you have two options for how you can set it up. The option that I like the best is to set it up as a triple inequality, which would look like this. Okay? If you would prefer not to do it that way, you can set it up as two separate inequalities, just like we did on the last one. The first one is less than 2. You have to put the and in between. And the next one is going to look exactly the same, just like we did on the last problem, but it's going to be greater than negative 2. So the sign switches in the middle, the sign on the right changes. So that part of it actually mimics and mirrors the last problem really, really well. So if you like that option, go for it. So here, I wanted to show you how you solve a triple inequality. I've already shown you how you solve two statements together. I mean, we've done several problems of that. But let me show you what happens when you have a triple inequality. So when you have a triple inequality, what it means is no matter what you do to one side, you have to do it to the other two. So there's 3 sides. So all 3 sides are going to be affected in the same way. So in the middle, for example, we're going to use our same order of operations to subtract 6 first, but I have to subtract 6 on all 3 parts. So negative 2 minus 6 would end up giving me what? Yeah, negative 8. Sign stays the same. I have negative 4x in the middle. And then 2 minus 6 is -4. Then my last step, of course, trying to get x alone, even though x is in the middle, I still want it alone, would be to divide by -4. And I have to do it to, again, all three sides. So on the, it's the direction. On the left-hand side, -8 divided by -4 is what? 2. In the middle, I have x. And on the right-hand side, -4 divided by -4 is 1. But I divided by a negative, which means all the inequalities switch, right? So my inequalities now go this direction. Feels a little bit awkward to have it written this way. I mean, we read from left to right, but we could read this from right to left and rewrite it if it's bothersome, and it would end up looking like this if we switched it. So on a number line, we would have our 1 and our 2, our 1 and our 2. And it's an and statement. So if we were doing it from the other equation, the other inequalities that I set up, we would have overlapping pieces in the middle. If we're doing it from this triple inequality, you could already see that what we're shading is actually in between 1 and 2, because that's where the x is located. It's between 1 and 2. So my shading actually goes right here. Do I use parentheses or brackets? Parentheses, because I don't have those equal signs, right? And so my interval notation is from 1 to 2. This is one of those unfortunate math things, because that looks like the ordered pair 1, 2 as well. I'm really sorry about that. I didn't make it up. But it's an interval. Any questions on that? All right, so this lesson will be due on Monday. You also have a test on Monday, but we do have to finish up this lesson for Monday as well. That is doing the homework for it.